Europa Clipper is set to explore Jupiter's icy moon Europa, one of the most intriguing destinations in our solar system. Scientists believe beneath its icy crust, Europa hides a vast ocean, making it a prime candidate in the search for life beyond Earth. The mission team has been working for over a decade to get us closer to answering some of our biggest questions. As we journey towards Europa, the spacecraft will fly by its surface 49 times, capturing high-resolution images, analyzing its icy shell, and measuring the magnetic fields that reveal the mysteries of its hidden ocean. Powered by the largest solar panels NASA has ever flown to deep space, Europa Clipper will take us 1.8 billion miles, uncovering new data that could redefine our understanding of ocean worlds. Join us as we explore the unknown and search for answers. Could Europa harbor life? Stay tuned for the launch and beyond, because the real journey of discovery is just beginning. As Europa Clipper hurtles through space, it's equipped with some of the most advanced scientific instruments ever designed. These instruments are key to unlocking the secrets of Europa's mysterious surface and the ocean beneath. Let's start with the magnetometer, a crucial tool that will measure Europa's magnetic field. By detecting fluctuations, the magnetometer can help scientists determine the depth and salinity of the subsurface ocean. Knowing these details could give us a clearer picture of whether Europa's ocean is habitable. Next, the ice-penetrating radar, or REASON, is designed to peer through Europa's icy shell. Think of it like X-ray vision for planets. This radar will map the thickness of the ice, which could be up to 15 miles thick in some places. But it's not just about thickness. REASON will also search for pockets of liquid water trapped inside the ice, potentially providing even more clues about how the surface interacts with the ocean below. One of the most exciting features of Europa's surface is the presence of chaos terrain, strange, broken-up areas that scientists believe could be the result of upwelling water from the ocean below. The radar will give us a clearer look at these features and tell us whether water is making its way to the surface from the deep. The thermal imaging system will detect heat emanating from Europa's surface. By scanning for warmer spots, Clipper can pinpoint areas where the ice might be thinner or where geological activity is happening, key indicators of potential habitability. The visible and infrared spectrometers will analyze the composition of Europa's surface. By looking at the way light interacts with the icy crust, these instruments can identify what chemicals are present, particularly organic compounds that could be the building blocks of life. Scientists are especially interested in the reddish-brown streaks seen across Europa's surface. Could these mysterious markings contain clues about what lies beneath? But that's not all. Clipper will also carry a dust analyzer designed to study particles ejected from Europa. Scientists suspect that plumes of water vapor might erupt from cracks in the icy crust, much like the geysers on Saturn's moon Enceladus. If Europa is venting material from its ocean into space, Clipper could fly through these plumes, analyzing their composition and giving us a direct sample of what's below the surface. In addition to these high-tech tools, Clipper's cameras will deliver stunning, high-resolution images of Europa's surface. With each flyby, we'll get a closer look at the moon's chaotic landscape, searching for any signs of current geological activity and mapping the surface in unprecedented detail. And while the primary focus of this mission isn't to directly search for life, every piece of data Clipper sends back will be crucial for determining whether Europa could support life. The conditions for life as we know it, liquid water, essential chemicals, and energy sources, are believed to exist here. But the question remains, is Europa's ocean truly habitable? Each of Clipper's 49 FLYBYS is planned to study different parts of Europa's surface. The spacecraft will pass within 16 miles of the surface, closer than any mission has ever come. These close passes will allow Clipper to capture the most detailed images and data possible, while avoiding the harshest areas of Jupiter's radiation belt. Speaking of radiation, Europa Clipper faces a daunting challenge. Jupiter's immense magnetic field creates a highly radioactive environment that can be hazardous to spacecraft. To protect Clipper's sensitive instruments, engineers have built a special radiation vault, a titanium box that shields the electronics from Jupiter's punishing radiation. This vault will ensure the spacecraft survives its long mission in one of the most extreme environments in the solar system. Now, let's talk about the spacecraft's journey itself. Launching aboard a Falcon Heavy rocket, Clipper will make its way to Jupiter by using gravity assists from both Earth and Mars. This technique will help slingshot the spacecraft deeper into space, conserving fuel and ensuring it has enough power to complete its mission. Even with these gravity assists, the trip to Jupiter will take over 5 years, covering a distance of 1.8 billion miles. Once there, Europa Clipper will begin its detailed study of this intriguing moon, sending back data over the course of its 4-year mission. But the journey doesn't end there. After Clipper has gathered its data, the information it provides will set the stage for future missions, possibly even a lander mission to Europa's surface. Imagine landing on this icy world, drilling through the ice, and directly sampling the water below. It's a bold vision for the future of exploration, and Clipper's findings will be critical in shaping those future missions. This mission is the culmination of decades of work from scientists, engineers, and space enthusiasts alike. Over 4,000 people have contributed to Europa Clipper, from its conception to its launch, and every day brings us closer to uncovering the mysteries of Europa's ocean. The Europa Clipper mission is more than just a spacecraft, it's humanity's next step in the search for life beyond Earth. With each new discovery, we expand our understanding of what makes a world habitable and where else in the universe we might find life. The icy moon of Europa holds so many secrets beneath its frozen surface, and soon Europa Clipper will begin unlocking them. From its towering ice cliffs to the vast ocean hiding beneath, this mission will bring us one step closer to answering a question that has fascinated humanity for generations. Are we alone in the universe? Now, let's take a closer look at why Europa is so special and why NASA has invested so much time and energy into this mission. Europa is one of Jupiter's 4 largest moons, known as the Galilean moons, discovered by Galileo Galilei in 1610. At first glance, it might seem like just another frozen moon in the outer solar system, but appearances can be deceiving. Beneath its icy shell, Europa is thought to harbor a vast ocean, containing more than twice the water found on Earth. But how do we know this? The evidence comes from decades of exploration and study, starting with the Voyager missions in the 1970s. These spacecraft provided the first close-up images of Europa, revealing an ice-covered world with very few impact craters. This indicated that the surface was relatively young and had likely been resurfaced by some form of geological activity, unusual for a moon in the outer solar system. This was the first clue that something extraordinary might be happening beneath Europa's frozen exterior. Then, in the 1990s, NASA's Galileo mission provided even more tantalizing hints. By measuring Europa's magnetic field, Galileo detected anomalies that suggested the presence of a conductive layer beneath the surface, most likely a salty ocean. The spacecraft also captured images of chaos terrain, vast regions of jumbled ice blocks that appear to have broken apart and refrozen. This could be evidence of water welling up from beneath the surface, further supporting the theory of a subsurface ocean. But why does this ocean exist in the first place? Europa's ocean remains liquid due to a process known as tidal heating. As Europa orbits Jupiter, the immense gravitational pull of the gas giant causes the moon to stretch and compress slightly in its elliptical orbit. This constant flexing generates heat within Europa's interior, preventing the ocean from freezing solid. This same tidal heating could also drive underwater hydrothermal activity, another key ingredient for life. As we've learned from Earth's own oceans, life can thrive in the most extreme environments, including the deep sea, where sunlight never reaches. Hydrothermal vents at the bottom of our oceans provide the necessary energy and nutrients for life, even in the absence of sunlight. It's possible that similar conditions exist beneath Europa's icy shell, making it one of the most promising places in our solar system to search for signs of life. Europa Clipper's suite of instruments is specifically designed to investigate these possibilities. Let's talk more about some of the mission's key objectives and how they align with the search for life beyond Earth. First, Europa Clipper will work to confirm the presence and characteristics of Europa's ocean. We know that liquid water exists beneath the ice, but questions remain about its depth, composition, and interactions with the surface. By using the ice-penetrating radar, Clipper will create detailed maps of the ice's thickness and detect subsurface lakes that could act as conduits between the ocean and the surface. These lakes might provide more accessible environments for potential life, offering a glimpse of the conditions in the ocean below. Next, Clipper will study the chemistry of Europa's surface in unprecedented detail. One of the biggest questions is whether the ocean contains the necessary ingredients for life, such as organic molecules. The visible and infrared spectrometers aboard Clipper will analyze the composition of Europa's surface ice, searching for complex carbon-based molecules that are crucial for the formation of life as we know it. These molecules could be brought to the surface by upwelling water or even through the geysers that scientists believe might be venting from Europa's ocean. Imagine the possibility water from Europa's ocean erupting into space, carrying with it clues to the moon's habitability. If Clipper can detect and analyze these plumes, it could give us a direct sample of what lies beneath the ice, without the need for a lander or drilling equipment. This is a game-changing opportunity for planetary science, and one of the mission's most exciting goals. But even if Europa's ocean is habitable, what would life look like there? It's unlikely we'll find anything resembling fish or whales. Europa's environment is far too extreme for large organisms. Instead, we're looking for microbial life, similar to the bacteria that thrive in Earth's deep-sea hydrothermal vents. These microbes don't need sunlight to survive. They use chemosynthesis, a process that converts chemicals, rather than sunlight, into energy. Europa's ocean, rich in salts and potentially interacting with the moon's rocky mantle, could provide the necessary ingredients for life to exist in a similar way. In addition to exploring the ocean's chemistry, Europa Clipper will also investigate geological processes on the surface. The moon's ice shell is a dynamic environment, constantly being reshaped by tidal forces. By studying the chaos terrain and ridge systems, Clipper will help scientists understand how the ice moves and interacts with the ocean below. This could reveal how nutrients from the ocean might be cycled to the surface, a key factor in determining the habitability of Europa. Europa's surface also holds another clue: radiation. While Jupiter's intense magnetic field bombards Europa with radiation, this might not be entirely bad news. The radiation could break down molecules on the surface, creating a layer of oxidants that could act as food for any potential life forms in the ocean. Clipper will study the effects of this radiation and how it alters the surface chemistry, giving us more insight into how Europa's environment could support life. As we dive deeper into Clipper's mission, let's not forget about the challenges this spacecraft faces. One of the most significant is Jupiter's powerful radiation belts. Orbiting within these belts, Europa is bombarded with high-energy particles, making it one of the most extreme environments for a spacecraft. The engineering team behind Europa Clipper had to design the spacecraft to withstand this harsh radiation, using a combination of shielding and careful planning to ensure it can operate long enough to gather the data we need. Clipper's instruments are housed inside a titanium radiation vault, which protects the electronics from radiation damage. But the team didn't stop there. Each of Clipper's 49 FLYBs of Europa has been carefully planned to minimize the spacecraft's exposure to the most intense radiation. Between FLYBYs, Clipper will spend most of its time in the relatively safer environment of Jupiter's outer magnetosphere, sending data back to Earth and preparing for its next close pass. Every flyby brings us closer to answering one of the most profound questions humanity has ever asked. Are we alone in the universe? Europa Clipper is designed to gather the data that will help us determine whether this icy moon could support life. but it's only the beginning. The results from this mission will guide future missions, including potential landers or even more ambitious efforts to drill through the ice and directly sample the ocean. Just imagine a future where we send a spacecraft to Europa equipped with a drill capable of reaching the liquid ocean below. The water samples brought back could finally reveal whether Europa's ocean is home to alien microbes or even more complex forms of life. The implications of such a discovery would be staggering, not just for planetary science, but for humanity as a whole. The Europa Clipper mission represents the cutting edge of space exploration, a mission that stands on the shoulders of giants, from the Voyager and Galileo missions to Cassini and beyond. Each step has brought us closer to understanding the outer solar system and our place in the universe. With Clipper, we're taking a giant leap forward in that journey. As Clipper prepares to launch, it's important to remember that space exploration isn't just about answering scientific questions, it's about expanding the human experience. Missions like Europa Clipper inspire curiosity, wonder, and a sense of adventure. They push the boundaries of what we know and what we can achieve, reminding us that we are a species of explorers. The exploration of Europa is only one chapter in the broader story of space exploration. With missions to the Moon, Mars, and beyond, NASA and its partners are paving the way for the next generation of explorers. Perhaps one day, humans will set foot on these distant worlds, and the data from Europa Clipper will be a crucial part of that journey. So, as we prepare for this monumental mission, we invite you to follow along, share in the excitement, and wonder at the mysteries that await us beneath the icy crust of Europa. Who knows what we'll discover? As Europa Clipper sets off on its 5.5-year journey through space, it carries the hopes and dreams of a generation of scientists, engineers, and space enthusiasts. But the significance of this mission extends far beyond the confines of science labs and control rooms. It touches on fundamental human questions that have echoed through history. Where do we come from? Are we alone? What is our place in the cosmos? For millennia, humanity has looked up at the night sky, wondering if life exists elsewhere in the universe. From the earliest astronomers to the latest robotic explorers, we have relentlessly pursued answers to these questions. Europa, with its vast, hidden ocean, is one of our most promising leads. The data collected by Clipper could not only revolutionize our understanding of this icy moon, but also provide a glimpse into the possibility of life on other ocean worlds, both within our solar system and beyond. One of the most exciting aspects of the Europa Clipper mission is how it connects to the broader search for ocean worlds. In recent years, scientists have realized that planets and moons with subsurface oceans might be far more common than we once thought. Jupiter's moon Europa, Saturn's moon Enceladus, and even some of the moons of Neptune and Uranus could all harbor vast oceans beneath their icy crusts. What if, instead of rocky, Earth-like planets being the most likely candidates for life, it's these ice-covered ocean worlds that hold the greatest potential for habitability? This shift in thinking has transformed the way we explore the solar system. Missions like Cassini, which revealed the icy geysers of Enceladus, and now Europa Clipper, are leading the charge in this new era of exploration. As we gather more data, we'll be able to refine our search for life, not just in our own solar system, but in the exoplanets orbiting distant stars. This brings us to one of the most profound implications of the Europa Clipper mission. What we learn from Europa could help us in the search for exoplanets. Over the past 2 decades, astronomers have discovered thousands of planets orbiting stars beyond our solar system. Many of these planets are in the so-called habitable zone, the region around a star where conditions might be right for liquid water to exist on the surface. But what if some of the most promising worlds for life are not located in the habitable zone at all? What if, like Europa, they orbit far from their parent stars, locked beneath thick layers of ice? These distant ocean worlds, heated not by sunlight but by tidal forces or radioactive decay, could be some of the most common environments in the universe. And just like Europa, they could harbor life in their hidden oceans. By studying Europa in detail, Europa Clipper will give us a model for understanding these alien worlds. The way water interacts with ice, the chemistry of the ocean, the effects of tidal forces, all of these factors will help us determine which exoplanets might have oceans beneath their surfaces and which could potentially support life. As we venture further into the future of space exploration, collaboration between missions will become even more essential. Already, NASA and the European Space Agency (ESA) are working together to explore the outer solar system. While Europa Clipper is headed to Jupiter, ESA's JUICE mission is on its way as well, set to explore not only Europa, but also Ganymede, another of Jupiter's moons that could have a subsurface ocean. Together, these missions will give us a comprehensive understanding of Jupiter's moons, their oceans, and their potential to harbor life. This international collaboration represents the next phase of space exploration, where missions are not only designed to stand alone, but also to complement each other. With Europa Clipper and JUICE both in the Jovian system, we'll be able to conduct joint observations, compare data, and deepen our understanding of these icy worlds. But this is just the beginning. The data gathered by Clipper and JUICE will inform future missions, perhaps even human exploration of the outer solar system. Imagine astronauts venturing to Europa, drilling into its icy surface, and sending robotic submarines into the ocean below. It sounds like science fiction today, but the technology to make it a reality is already being developed. As we continue to push the boundaries of what's possible, missions like Europa Clipper lay the groundwork for these bold new ventures. And the implications of such discoveries are not just scientific, they are deeply philosophical. If we find signs of life on Europa or elsewhere in the solar system, it will raise profound questions about our place in the universe. Is life a cosmic accident, unique to Earth, or is it a common outcome of the right conditions, scattered throughout the stars? Discovering life on another world would forever change the way we see ourselves and our role in the cosmos. Even if we don't find life, the lessons learned from Europa will be invaluable. The search for life isn't just about answering the question, "Are we alone?" It's also about understanding the nature of life itself. By studying the extreme conditions on worlds like Europa, we learn more about the resilience of life, the diversity of environments where it can exist, and the possibilities for life's origins. Europa Clipper is a mission that exemplifies the best of what humanity can achieve when we work together to explore the unknown. It's a mission that blends cutting-edge technology with age-old curiosity, pushing the boundaries of science while inspiring a new generation of explorers. In the coming years, as Europa Clipper sends back its first data, we'll get our clearest view yet of this mysterious world. The excitement will build with each flyby, each new image, each new piece of data, bringing us closer to the answers we seek. And as those answers come in, they will shape the future of space exploration for decades to come. As you watch this mission unfold, remember that this is just the beginning. Europa Clipper is part of a grander journey, a journey that will one day take us beyond the icy moons of Jupiter, beyond the outer planets, and perhaps even beyond our solar system itself. The discoveries made by this mission will ripple through time, influencing how we think about life, the universe, and our place within it. So join us on this incredible adventure. As Europa Clipper embarks on its epic voyage, we invite you to follow along, ask questions, and share in the wonder of exploration. Whether we find life or not, we will learn more than we ever imagined about this icy world and the ocean that lies beneath its surface. The search for life is one of humanity's greatest quests. Europa Clipper is a major step forward in that journey, and the possibilities what we might find are limitless.